Consider a parabola with equation y equals to x squared. A circle touches the parabola at 2 points a 1, 1 and b negative 1, 1. Find the radius of the circle. First of all, based on the symmetry of the figure, the center of the circle lies on the y-axis. Let the center be C, 0h, and the radius be r. Now, we have two unknowns h and r, so we need two equations to solve them. For the first equation, we consider the length of CA, which is equal to the radius r. By distance formula, we have square root of bracket 1 minus 0 whole square plus bracket 1 minus h whole square equals to r. We square both sides and expand the perfect square term as 1 minus 2h plus h squared. Therefore, r squared is equal to h squared minus 2h plus 2. Let's call this equation 1. It will be very useful at the end of the question. Let's keep this in mind. For the second equation, you might think that we make use of the length of CB. However, after some calculations, it gives exactly the same equation 1. So we need another way to work it out. Let's figure out the equation of circle, which is bracket x minus 0 whole square plus bracket y minus h whole square equals to r squared. We put equation 1 into the right hand side. Now, apart from the two variables x and y, there is only one unknown constant h. Let's call this equation 2. We move on to the equation of the parabola, y equals to x squared. Let's call this equation 3. Alright, everything is ready. What we're going to do is to put equation 3 into equation 2 like this. Therefore, this equation gives the x-coordinates of the points of intersection. Let's simplify it. We expand the perfect square term on the left-hand side, which is bracket x to the power 4 minus 2hx squared plus h squared. Here, we can cross out the terms h squared on both sides. Then we make x as the subject of the equation. So we have x to the power 4 as the first term. We also group the x squared terms together. That is x squared times bracket 1 minus 2h. For the remaining terms, we put them to the left. So it is 2h minus 2 equals to 0. Let's call this equation 4. Then how can we solve this equation? We're going to play some tricks on it. Let z equals to x squared. Then it can be written as z squared plus z times bracket 1 minus 2h plus bracket 2h minus 2 equals to 0. Now, it is reduced to a quadratic equation. More than that, because the solutions of equation 4 are the x-coordinates of the points of intersection, so x is equal to 1 or negative 1. Because z is equal to x squared, therefore, in both cases, z is equal to 1. That means if we look at the quadratic equation right here, it has only one real solution. And this is the most important part of the question. Therefore, we can say that the discriminant is equal to 0. That is, bracket 1 minus 2h whole square minus 4 times 1 times bracket 2h minus 2 is equal to 0. Now, we have only one unknown h to solve. Again, expand and simplify the equation, we get 4h squared minus 12h plus 9 is equal to 0. It can be factorized easily as bracket 2h minus 3 whole square is equal to 0. So, h is equal to 3 over 2. To solve for r, still remember equation 1 at the beginning? We put the value of h inside. Then r squared is equal to 5 over 4. That is, the radius r is equal to square root 5 over 2. You see, we can solve this coordinate geometry problem without using any calculus. Are you looking for more challenging questions in geometry? Check out the next video right here on the screen. I will see you there.